Welcome to this review on ratios. Just a few things noted here in this gray box. A ratio can be separated by a colon, by the word to. It can be written as a fraction. And if you take that fraction and divide it, you can actually then write it as a decimal where the bottom number would be a 1. And you do that if you want to say per a single unit or whatever that may be. So the first thing we're going to do is look at part-to-part ratios. So we're looking at max to PCs. So if we say 2 to 6, we would say there are 2 max for every 6 PCs because that's what it implies. Max are first, PCs come second. Well, 2 to 6, those are both even numbers, so we could reduce. And if you reduce 2/6, you would get 1/3. Think about that as a fraction. So 2/6 would reduce to 1/3. So really, there is 1 mac for every 3 PCs. Same information, we just reduced it. And you can see in the third spot, you can write that as a fraction, which we did. We put that up here. So there's 1 mac for every 3 PCs. That's the same thing that it meant, whether you write it as with a colon or the word to, or as a fraction, you have the same meaning. Now, if you take that fraction, that 1/3, and you divide it, that's what you get here, this 0.33. And I like how they write it here over 1. So 0.33 over 1, that's max to PC. So there are 0.33 max for every 1 PC. So there's a couple different ways you can think about it, but if you see somebody with 1 mac, then you would expect to see 3 PCs there. Or if you have somebody with 1 PC, only 1/3 of a mac would be expected, which I don't think anyone's going to take their mac and cut it into 3 pieces, but it's, that's the process that we're thinking about here. So let's go ahead and look at our own example here dealing with part to whole. So when you have part to whole, you can see that we have 2 max, 6 PCs, and that gives us 8 total. So the total would be the whole, if you will, because that's all of them. So when I look at this, I want to talk about max. So we know there are 2 max, and that's what we're going to use. So there are 2 to 8, 2 max out of every 8 computers, or 2 to 8, right? Either way. Now, hopefully you recognize that 2 over 8 can be reduced to 1/4. So 1:4, 1/2/4, 1 mac for out of every 4 computers. So if there are 4 computers in a room, we would expect one of those to be a mac. In lowest terms as a fraction, that would be 1/4. So 1/4 of the computers are max. Now, we can take that fraction, divide it, and we would get 0.25. So 0.25 to 1. There are 0.25 max for out of every computers, for every computer. Change that to a percent, you get 25%. So 25% of the computers are max. You can only use percents when you are talking part to whole. So notice, part to whole is when we can use percent. And I would say that's probably the most efficient way to talk about things when you're going part to whole. It's easy to say, 30% of your total grade comes from this test or whatever. Part to whole, percent is the easiest way to think about it. Okay, so we know at the bottom of page 288, you see this empty table, and we're supposed to do a class tally, but we don't have a class. This is a video, so I just created some numbers so you can see the numbers that I created up here, and I would like you to hit pause and use those numbers to fill in your table, and don't forget to reduce. Okay, in all the different forms. So you can write it with the word to, as a colon, as a fraction, change that fraction to a decimal, and then recognize, is it part to part or part to whole? And remember, as a percent, you can only use that if it's part to whole. So if it's part to part, you would just want to put an X because it is not applicable. Okay, so hit pause, fill in this table, and then come back and check out my completed table. Okay, so here's the completed table. Notice I did reduce. Where it says students, that's the total, which would be 60. And I highlighted this last thing where it says students to drama. So students is total, so this is really whole to part. So you can see whole to part, 6 to 1. But when I get over here to the percent form, I kind of flipped it, and I made it 1/6, so that's drama over the total. So 16.7% of students like drama. That's what that last piece means, and I wanted to highlight that so that you could see that little bit of a difference. And now we're going to use these to interpret a little bit. So using your completed table, in a meaningful sentence, write the ratio of students whose favorite genre of movie is suspense to students whose favorite genre is drama. So we're going suspense to drama, okay, which you've already done, and we know that answer is 3/5. So a good sentence would be, there are 3 students who favor suspense for every 5 students who favor drama. Now, if you had gone a step further and made that a decimal, then you would say there are 0.6 students who favor suspense for every student who favors drama. Either way is fine. Letter B, write the ratio of students, well, in a meaningful sentence, comedy to total. So we're doing comedy to total. So comedy, if you reduce that, you end up with 1/4. Now, because we are doing part to whole, we can write this as a percent. So 1/4 is 0.25, which is 25%. So I'm going to write this as a sentence. So 25% of all students prefer comedy. Boom. Done. All right, now in number 2, again, we needed some data, and since we didn't have a class, I made it up. So 7 people were born in the same county, 6 in the same state but elsewhere, 8 were in another state, and then 2 in another country. So if you'll notice, that gives us 23 total. So that's how many students we're playing with in this example. So we want to write the ratio of students born in the same county to students born in another state. Okay, so same county is 7, and then another state is 8. So there's one way. 7 to 8, there's another way, or 7:8, there's a third way. Now this, hopefully you recognize that this is part to part because the total, which is 23, is nowhere to be found. So a meaningful sentence, I actually wrote two sentences for you. So the first one is kind of basic. There are 7 students born in the same county for every 8 students born in another state, and then compare that to there are 0.875. That would be 7 over 8, change it to a decimal. There are 0.875 students born in the same county for every 1 student born in the same state. Sorry, that's another state, not the same state. I apologize for that statement. All right, and letter B, using that same information, look at my typo, we want to do the ratio of students born in the same state to total students in 3 different ways. Now, when we say same state, that's same state but elsewhere. So that answer would be the 6 over the 23. So now this is part to whole, which should make you think percent. So 6 over 23 is 0.26, so that's 26%. So 26% of students were born elsewhere in Indiana. And there would be your cents. I prefer part to whole because then you can write them as percents and it makes it a little bit easier. And I'm all about making things as easy as possible. So that's the end of this video. If you have questions, let me know.